All right, welcome. So, if you're ready to make your code more powerful, more organized, and just way less repetitive, then you are in exactly the right place. Today, we're diving deep into one of the most fundamental building blocks in all of programming, Python functions. Let's get right into it.
You know that feeling, right? That sense of déjà vu where you're just grinding away at the exact same task again and again? Well, it turns out in programming, that feeling is a major red flag.
And in the world of code, that feeling looks, well, it looks a lot like this, just copying and pasting the same line over and over. I mean, sure, it works, but it's clunky, it's really hard to read, and it's an absolute nightmare to update. Think about it. If you need to change do something, you have to go hunt down and fix every single copy. No thanks.
So this gets at a really core principle in software, which is don't repeat yourself. You'll often hear it called DRY. See, good programming is all about being efficient, and repeating yourself is pretty much the opposite of that. It's not just tedious, it's a recipe for introducing bugs.
Okay, so how do we fight back against all this repetition and keep our code nice and dry? Well, our first tool in the toolbox is the loop. It's a much smarter way to handle tasks that you know need to be done a specific number of times.
I mean, look at this. It's so much more elegant than just copy-pasting, right? This one little line, for I in range 3, basically tells the computer, hey, see that code indented below me? Run it exactly 3 times. So much cleaner.
Okay, but here's a crucial little detail that trips up a lot of people when they're starting out. When Python's range of 3 starts counting, it doesn't start at 1. See, in the world of computer science, we start counting from 0. So the very first pass through the loop kicks off with 0.
The second pass is 1.
And the third and final pass is 2. So range 3 gives you the numbers 0, 1, and 2. It goes right up to 3, but it never actually includes the number 3. That's a super important concept to lock in.
Now, loops are fantastic, don't get me wrong, but they do have their limits. They're perfect when you have a fixed number of repetitions. But what happens when the problem gets a little more complex? What if you need a reusable tool that you can pull out and use anytime, with different inputs to get totally different results?
And that brings us to the star of the show today, functions. This is where we level up from just repeating code to creating these powerful, reusable tools. And to really get our heads around this, we're going to use what I like to call the toaster analogy.
This quote from our source material just nails it. A toaster does one job. It toasts things. You don't buy a brand new toaster every single time you want a piece of toast. Of course not. You use the same machine and you can put in a slice of bread, a bagel, whatever. The toaster is your reusable tool. And functions are your coding toasters.
So here's the bottom line. A function is just a piece of code that you give a name to. You write the logic once, you wrap it up, and then you can call that name from anywhere else in your program to run that code as many times as you want.
So how do you actually build one of these coding toasters? Let's break down the anatomy of a function, piece by piece.
All right, every single function definition in Python follows this exact pattern. You start with def, which is just short for define. Then you give your function a nice descriptive name, like average. Now, inside the parentheses are its parameters. Think of these as the input slots, just like the slots in a toaster. The colon at the end just signals, okay, the instructions for this function are about to start. And finally, you have return, which is the keyword that sends the finished product, the result, back out. This whole package is what we call an abstraction. It hides all the messy details of how to do something inside one simple, easy-to-use name.
Okay, so we've built our function. Now how do we actually use it? Well, we call it by its name. So on this line, mid equals average of 10.6, 7.2, we're basically telling Python, hey, go find that recipe I wrote called average and run it for me right now.
And this right here is where the magic happens. The values that we provide, 10.6 and 7.2, are passed into the function. They flow right into those placeholder slots we defined a second ago. So inside the function, the variable a becomes 10.6 and b becomes 7.2. So inside the function, the hidden code gets to work. It adds a and b together, then it divides that sum by 2 to get the average. The return statement then sends that final calculated value all the way back out to where the function was first called, and in this case, it gets stored in our mid variable.
Okay, time for a quick jargon check, because this is a spot where a lot of people get mixed up. The placeholder variables inside the function definition, like our a and b, those are called parameters. The actual values you provide when you call the function,
like 10.6 and 7.2, those are called arguments. The easy way to remember it is parameters are the empty slots and arguments are the actual things you slide into those slots.
So let's pull all of this together. We've seen the problem with just repeating code, we've seen how loops can offer a partial solution, and now we've seen how functions give us the ultimate reusable tool. Let's talk about why this is such a genuine game changer for your code.
So here's the big takeaway. First, reusability. Functions are the heart and soul of that don't repeat yourself idea. You define that average function one time, and you can use it all over your program without rewriting the logic. Second, organization. They're your #1 tool for abstraction. They let you break down a huge, scary problem into little, manageable chunks, hiding away the messy details. And finally, flexibility. By passing in different arguments, you get completely different results from the exact same block of code.
Ultimately, learning to write functions is like getting a brand new custom toolkit. You stop just using the tools that Python gives you, and you start building your own. You're no longer just a user of the language, you become a builder. So the real question is, what tool are you gonna build first?
All right, that's it for this explainer. Thanks for joining. Now get out there, stop repeating yourself, and go build something amazing with functions.